Welcome to the deep dive. Today we're journeying into a world that's usually hidden.
Beneath our feet.
Yeah, beneath our feet, a world that you've been digging into, the fascinating realm of
Mycorrhiza.
Mycorrhiza.
And it's a world
Is
absolutely teeming with complexity and wonder,
right.
even though it often gets overlooked.
Yeah, it's like there's a whole secret society operating down there, and we're here to uncover their secrets. You even sent over that excerpt from the Mycorrhiza Wikipedia page, which is a great starting point.
Yeah.
But we're going way beyond the basics today.
Absolutely. We're delving into those aha moments that really illuminate the profound role of these intricate relationships in the circle of life.
Okay, so for anyone just joining us, let's start with the fundamentals. What exactly are Mycorrhiza?
In essence, mycorrhiza are these ancient, mutually beneficial partnerships between fungi and plant roots. Think of it like this. The plant, through photosynthesis, generates sugars its own form of currency. It provides these sugars to the fungus. In return, the fungus, with its vast network of thread-like hyphae, becomes a master prospector, mining the soil for essential resources like water and nutrients, which it then delivers back to the plant.
So it's like a bustling marketplace down there, with plants trading their sugary goods for essential supplies. But we're not just talking about any old nutrients, right? These are the premium high-grade stuff that plants crave, the kind they can't always get on their own.
Precisely. We're talking phosphorus, nitrogen, and other micronutrients that are absolutely essential for plant growth, especially in nutrient-poor soils. These fungal networks can be incredibly vast, reaching areas and accessing resources that plant roots simply couldn't on their own.
That's amazing. It's like having a whole team of microscopic miners on the plant's payroll, venturing into the depths and bringing back these valuable treasures. So how common are these mycorrhizal partnerships? Is this a rare phenomenon, or are we talking about something more widespread?
Widespread doesn't even begin to cover it. We're talking over 90% of plant families on Earth engaging in these mycorrhizal associations. They are the rule, not the exception in the plant world. In fact, it's hard to imagine what our planet would look like without them.
Wow, 90%. That's mind-blowing. So it sounds like Mycorrhizae is a pretty broad term, kind of like saying trees.
Right.
You mentioned there are different types of these fungal partnerships.
Sure.
What are the key players in this underground world?
You are absolutely right. Just like trees encompasses a vast diversity of species, Mycorrhizae is a blanket term for a whole range of specialized partnerships. Let's start with the ectomycorrhizae, often shortened to ECM. These are the connoisseurs of the fungal world, forming sheaths around the root tips of their plant partners, but they're incredibly selective about their dining companions.
Picky eaters, huh? So who gets to sit at the table with these fungal gourmands?
They tend to partner with specific trees, think oaks, pines, and other woody plants. Instead of directly penetrating the plant cells, they create this intricate web around the root cells known as the Hardig net, where the exchange of nutrients and resources occurs.
A Hardig net. Sounds almost otherworldly. Now, you mentioned something earlier about a wood wide web. What's the connection between these ECM fungi and this intriguing concept?
That's where things get really fascinating. The Hardig net, formed by ECM fungi, isn't just limited to a single tree and its immediate fungal partner. These networks can expand outwards, connecting entire forests in a vast interconnected web. It's through this wood-wide web that trees can actually communicate and share resources with each other.
Okay, that's where I need you to slow down and break it down for me.
Yeah.
Trees are communicating with each other, like sending messages through this fungal network.
You got it. Studies have shown that trees can use these mycorrhizal networks to transport sugars, nutrients, and even chemical signals across vast distances. For example, a dying tree can actually transfer resources to its healthier neighbors, or a shaded tree can receive a boost of sugars from a sun-drenched companion.
That is absolutely incredible. It's like this whole other level of social networking is happening right beneath our feet.
Exactly, and we've only just begun to scratch the surface of understanding the complexity and sophistication of this underground communication system.
Okay, I'm already mind blown, and we haven't even gotten to the other types of mycorrhizae. What else is going on in this hidden kingdom?
Well, next we have the arbuscular mycorrhizae, or AM fungi. These are the workhorses of the mycorrhizal world, found in a vast majority of plant species, including many of the crops we rely on for food. Unlike their more selective ECM counterparts, AM fungi are less picky about their partners.
So less about exclusive partnerships, more about getting the job done. Tell me more about these fungal workhorses.
They're all about efficiency. These AM fungi get up close and personal, sending their hyphae right into the plant cells to form arbuscules, these tiny branching structures where the exchange of nutrients and resources takes place. It's a much more intimate connection compared to the ECM fungi.
So they're really getting in there, embedding themselves right into the plant's cellular structure. That's a whole other level of partnership.
It really is, and it's incredibly effective. These AM fungi are essential for the uptake of phosphorus, a key nutrient for plant growth, particularly in agricultural systems.
Okay, so we've got the gourmet chefs, the networkers, and the workhorses of the fungal world. Are there any other key players in this underground ecosystem we should meet?
There's a fascinating group known as ericoid mycorrhiza, thriving in acidic nutrient-poor soils, often partnering with plants like blueberries, cranberries, and heathers. They excel at breaking down complex organic matter, unlocking nutrients that would otherwise be inaccessible to plants. They're like the ultimate recyclers.
So if you find yourself wandering through a bog surrounded by blueberries, you'll know who to thank for your tasty snack.
Absolutely. But it's not just blueberries and cranberries. Then there are the orchid mycorrhizae, which are absolutely crucial for orchid survival, especially during those critical early stages of development. Orchid seeds are minuscule, practically dust-like, and they lack those internal energy reserves found in many other types of seeds.
How do they even manage to germinate and grow? It sounds like a real challenge.
That's where their fungal partners come in. These specialized fungi provide the essential nutrients and resources that orchid seeds need to sprout and establish themselves. It's a lifeline for these beautiful and often delicate plants.
It's incredible to think about how these different types of mycorrhizae have evolved such specialized partnerships with plants. It seems like each has its own unique set of skills and strategies for thriving in this hidden world beneath our feet.
Exactly. And these adaptations and partnerships have profound implications, not just for the plants themselves, but for the health of our entire planet.
This is all so fascinating, but we have to take a quick pause for a word from our sponsors. Don't go anywhere, because when we come back, we'll explore how these incredible mycorrhizal networks are playing a crucial role in the face of climate change. And we're back diving deeper into the fascinating world of mycorrhizae. Before the break, we were getting to know the key players in this underground network, the gourmet chefs, the networkers, the workhorses, even the recyclers and lifelines. It's incredible how much diversity exists in this hidden kingdom.
It really is. And each of these partnerships has its own story to tell its own set of benefits for both the fungus and the plant.
Speaking of benefits, we were starting to uncover some of the amazing things these mycorrhizae do for their plant partners. Like those AM fungi, the workhorses. They don't just connect with plant roots, they actually intertwine at the cellular level, right?
Huh.
What are the implications of that kind of close relationship?
Well, you mentioned earlier this idea of a team of microscopic miners working for the plant. That's a great way to visualize it. Those fungal hyphae, much finer than any plant root, can penetrate tiny crevices in the soil, expanding the plant's reach exponentially.
So it's like they're tapping into a whole network of resources that the plant wouldn't even know existed otherwise.
Exactly. It's all about increasing surface area, maximizing access to water and essential nutrients, especially in areas where those resources are scarce. In a way, these mycorrhizal fungi are like living extensions of the plant's root system, making them much more resilient, especially in challenging environments.
That makes a lot of sense.
Yeah.
But it's not just about accessing what's already there.
You're right.
You mentioned that ericoid mycorrhiza can actually break down complex organic matter, unlocking nutrients that would otherwise be locked away.
That's right. They're like the master chemists of the soil, producing enzymes that can break down tough organic compounds, releasing nutrients like nitrogen and phosphorus, making them available to the plant.
So it's a win-win. The plant gets a steady supply of essential nutrients, and the fungus gets a share of the sugary rewards from photosynthesis. But are there any other benefits we haven't covered yet?
Oh, there are plenty. We've only just scratched the surface. For example, did you know that mycorrhiza can actually help protect plants from diseases?
Wait, really? So they're not just providing food and water, they're acting like bodyguards too.
In a way, yes. Some mycorrhiza can release compounds into the soil that inhibit the growth of harmful pathogens, essentially creating a protective barrier around the plant's roots.
So it's like having a whole security system in place, keeping those nasty pathogens at bay.
Exactly. And some mycorrhiza can even trigger the plant's own immune system, making it more resistant to future attacks.
Wow, that's incredible. It's like they're giving the plant's immune system a good workout, preparing it for whatever challenges might come its way.
Precisely. And it gets even more fascinating when we start talking about stress tolerance, particularly in the face of things like drought and salinity, which are becoming increasingly problematic with climate change.
Okay, so we've gone from gourmet chefs and microscopic miners to bodyguards and now stress management coaches. Tell me more about how mycorrhiza help plants cope with these environmental challenges.
Well, remember those vast underground networks we talked about earlier? Those networks aren't just for communication and resource sharing. They also act like a giant water storage system. During times of drought, when water is scarce, those mycorrhizal fungi can tap into deeper water sources, providing a lifeline for their plant partners.
So it's like having access to a secret well that only the mycorrhizae know about.
Exactly. And when it comes to salinity, some mycorrhiza can actually help regulate the uptake of salt by the plant, preventing it from reaching toxic levels. They act like filters, allowing the plant to access the water it needs while keeping the harmful salt at bay.
Wow, these mycorrhizal fungi are truly multi-talented. They're like the ultimate survival partners for plants. But you mentioned something about a sticky substance, glomalin. What role does that play in all of this?
Ah, glomalin. This is where things get really interesting, particularly when we start talking about soil health and its connection to climate change.
Okay, I knew we couldn't talk about the fate of the planet without addressing the climate crisis. So how do these amazing mycorrhizal networks factor into that massive equation?
Well, you've probably heard a lot about the importance of healthy soils in the fight against climate change. They act like giant carbon sinks, pulling CO2 out of the atmosphere and storing it underground.
Right, which is a good thing, right? Less carbon in the atmosphere means a slower rate of global warming.
Exactly. And guess what plays a crucial role in building and maintaining those healthy, carbon-rich soils?
I have a feeling you're going to tell me it's our friends, the mycorrhiza.
You got it. Remember that sticky substance glomalin that I mentioned earlier? Well, it turns out that glomalin is a key ingredient in creating what's known as soil aggregate stability.
Okay, break it down for me. What does that mean exactly?
Imagine you're building a sandcastle. Dry sand just crumbles, right? But if you add a little water, you can create all sorts of shapes and structures. That's because the water helps bind the sand particles together.
Okay, I'm following you.
Well, glomalin acts like that water in the sandcastle, but on a microscopic level. It binds soil particles together, creating these stable aggregates that improve soil structure. These aggregates create spaces within the soil, allowing for better water infiltration, aeration, and drainage.
So it's like giving the soil a good, deep tissue massage, loosening things up, improving circulation.
Exactly. And those well-structured soils, thanks to glomalin, are not only better at retaining water and nutrients, they're also much better at storing carbon.
Okay, so this is all starting to make sense. Healthy soils, thanks in part to mycorrhizae and their glomalin production, are better at storing carbon, which helps mitigate climate change.
Yeah.
It's amazing how interconnected everything is. But we were talking about stress tolerance earlier.
Right. Well, it's not all good news when it comes to mycorrhiza and climate change. While these fungal networks can help plants cope with certain stressors, rapid changes in climate can actually disrupt these delicate symbiotic relationships.
Oh no, that doesn't sound good. Tell me more about these potential disruptions.
Well, as temperatures rise and rainfall patterns change, it can create a mismatch between the plant, the fungus, and the environment they've adapted to over millennia. This can alter the composition of fungal communities in the soil, leading to a decline in the diversity and abundance of mycorrhizal fungi.
So it's like climate change is throwing a wrench into the finely tuned machinery of this underground network, disrupting these ancient partnerships that have evolved over millions of years.
It's a real concern. Imagine a delicate dance where the steps have been practiced and perfected over countless generations. Suddenly, the music changes, the rhythm is thrown off, and the dancers struggle to find their footing. That's what's happening to many mycorrhizal relationships as the climate changes faster than these organisms can adapt.
That's a powerful analogy. So what does this mean for the future of our forests, our food systems, our planet? Is there any hope, or is this a lost cause?
There's always hope, and it lies in understanding. The more we learn about these mycorrhizal networks, the better equipped we'll be to protect them and even harness their power for good. For example, you mentioned in your initial research some articles about using mycorrhizal fungi in agriculture. What are your thoughts on those approaches?
Well, the idea of using mycorrhizal inoculants, basically introducing beneficial fungi into the soil to support crops, seems incredibly promising, almost like giving our agricultural systems a probiotic boost.
It's an area of active research, and it has the potential to reduce our reliance on chemical fertilizers and pesticides, both of which can have negative impacts on soil health and the environment. By promoting healthy mycorrhizal communities, we can help create more resilient and sustainable agricultural practices.
That makes a lot of sense. But what about our forests? Those vast ecosystems with their ancient interconnected networks of trees and fungi, how do we even begin to protect something so complex and widespread?
It starts with awareness. Recognizing that beneath the surface of those towering trees lies this hidden world essential for their survival and the health of the entire ecosystem. Protecting existing forests, promoting sustainable forestry practices, and even restoring degraded lands with mycorrhizal fungi, these are all steps in the right direction.
It's amazing to think that something so small, so often overlooked, could hold such immense power. The power to connect, to nourish, to protect, and perhaps even to heal.
It really makes you appreciate the interconnectedness of all living things, doesn't it? And it underscores the importance of protecting the biodiversity of our planet from the smallest microbe to the tallest tree.
Absolutely. Well said. And on that note, we've reached the end of our deep dive into the incredible world of mycorrhiza. We'll be sure to link to all the resources we mentioned, plus some bonus materials in the show notes.
Thank you for having me. It's been a pleasure exploring this fascinating topic with you.
The pleasure is all ours. And to our listeners, thank you for joining us on this journey beneath the surface. Until next time, keep those brains buzzing and never stop questioning, because the more we learn about the natural world, the more we realize how much more there is to discover.